Can one experience change your life? We believe the unlimited potential of consciousness has been untaught and untapped. Together, we can change that. The LightNet community was born as a citizen science discovery lab. Can our collective curiosity help us see the world in a whole new light? We're here today with Professor Avi Loeb, who received a PhD in plasma physics at age 24 from the Hebrew University of Jerusalem. And he was a long-term member at the Institute for Advanced Study in Princeton, where he started to work in theoretical astrophysics. He moved to Harvard University, where he's been for decades. He's the founding director of Harvard's Black Hole Initiative. He moved to Harvard University Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics.
Hi there, I'm Zenka from LightNet, where we allow you to experience something extraordinary. I'm here today with Avi Loeb from Harvard University, and we're so excited. He's going to be talking about things that he doesn't normally talk about. We're going to ask him about time travel, spaceships, of course. We're going to talk about his daily life. So sit tight. Here we go. Welcome, Avi.
Thanks for having me. It's a great pleasure.
Yeah. So the first question I had for you was really, my friend calls it a mic drop. When you basically caused one of the biggest mic drops in academia that we have lived through by following your curiosity and putting your curiosity ahead of your ego. What was that like, and what were some of the challenging parts of doing that?
Well, I didn't really mean it. In 2019, I got a phone call from Leslie Meredith, who is now my literary agent, and she asked me if I want to write a book about my research because apparently it's very intriguing. And I said, no, I want to focus on my scientific research, forget about it. And then she called me again. It was sort of like a date where someone convinces you that you need to continue dating with them. And I at first declined because my main focus was research. But then I decided to cast my bread over international waters in the spirit of the biblical term. And then it was quite remarkable. After the book came out, I had about 1,800 interviews within a year and a half. And there was a huge amount of interest. And I used it as a way of communicating how science should be done, driven by curiosity, not by our ego. While a lot of people outside academia agreed with me, some people within academia kept pushing back. And I can give you various examples, but let me give just one of each response. For example, I was in Las Vegas with 800 women in the International Women Forum about a month ago. And I first obviously asked my wife if she allows me as the only man in a group of 800 women in Vegas. And she said, go ahead, take an extra day, which you can interpret in two ways. Either she rolls the dice or she trusts me. And it's probably the second interpretation that is right. And it was amazing. I mean, this experience, and a lot of excellent questions. And also when I got into the elevator at the hotel, I met a few conference attendees, and they wore their name tags. And they asked me, what are you here for? And I said, I'm supposed to participate in the session on Are We Alone? That was the title of the session. And I said, that's not a logo, not a slogan from a dating app. That's actually a question that humanity is supposed to ask. And they were extremely interested. And altogether, like a week later, there was an Iranian-born entrepreneur, a young woman that came to me and said, can I have a selfie with you? And then she posted it on Instagram and came back to me and said that I have hundreds of followers among Iranian women, scientists, that follow my work. And I said, I never heard about that. And 2 days ago, I had a young woman from Israel that came to my home and volunteered to participate in the Galileo Project. So altogether, a very favorable response. We have 100 members of the Galileo Project and about 1,000 applicants that want to volunteer. And so, that was a very rewarding experience. After casting my bread upon international waters, after many days, I did get rewarded, just like the biblical phrase says. But in academia, I received a huge pushback. And just to give you an example, I was discussing an object that looked really weird that came from outside the solar system. And I basically said, well, it doesn't look familiar, okay? And it has properties that are quite anomalous. It's an outlier in many respects. And I suggested maybe it's artificial in origin. And then 2 months ago, a colleague of mine says, I just finished writing a big review paper about this object, which was called the Oumuamua, which means a scout in the Hawaiian language. And he said, I wrote this review about the comet Oumuamua. And I asked him, what do you mean the comet Oumuamua? It didn't look like a comet. There was no cometary tail. And he said, well, I have this theory that when we didn't look at it, it had a cometary tail. And when we looked at it, it didn't. And I said, well, that's just like going to the zoo and looking at an elephant and saying, well, it's actually a zebra, because when I don't look at it, it may show its stripes. And this was supposed to be a mainstream overview that details all the information we have about Oumuamua and is authoritative. And it just shows you that how the description is not necessarily honest, even when it comes from mainstream in academia. And you ask yourself, why should it be that way? I mean, after all, academia is about blue sky research. It's about open-mindedness. Well, apparently not, because a lot of the work in academia is about showing off, showing that we are smart, getting honors, awards from colleagues. And for that purpose, what you want to do is go in the beaten path and basically impress other people, minimize the friction by following what everyone else is saying, rather than deviating from the beaten path and exploring the road not taken. So unfortunately, that very often leads to lack of innovation, to suppression of independent opinions, and it discourages young people from exploring uncharted territories, even though, the road not taken offers low-hanging fruit very often.
Yeah, that's incredible. I'm so glad that you've become a hero to Iranian women, people in Vegas, like you really are. And do you think that you've become a hero in academia and as well? Like, are you starting to see that it's loosening up and people that are in other fields, for example, are saying, okay, wait a minute, I just want to say what's on my mind, or I want to explore this topic?
Well, yeah, it looks to me like there is a shift, because, I remember that when I wrote my book, there was a congressman who for many years made anti-gay statements. And then when this congressman retired, he confessed that he is gay. Okay, so that shows you that many people who are making negative statements perhaps are intrigued and are really interested in that possibility, and they just fight against themselves in some way. And so that's part of human nature. But in terms of seeing evidence for a shift, so in 2019, I was invited for an interview about a meteor, and that led me to find a website that the US government compiled of meteors that they detected with satellites, with ground-based sensors. And I asked my student to check that catalog of meteors, about 273 of them, to see if any of them is moving too fast to be bound to the sun, because that will be an object that came into the solar system from outside. And we found one from January 8, 2014. And then we submitted a paper for publication about it. And the reviewers of the paper, mainstream astronomers, said, rejected. We are not allowing this to be published because we don't trust the US government. And I thought to myself, well, the US government deals with matters of life and death. You know, they have to protect the nation against ballistic missiles, and they need to know whether the ballistic missile is going to hit Boston or New York City. So they probably have very good data. But the paper was declined despite my best efforts. And then I tried a different approach, which is basically to approach people behind the national security fence in government to perhaps make a statement about how reliable the data is. And it took a few years. And then in March 2022, this year, there was a letter sent from the US Space Command under the Department of Defense, basically stating at the 99.999% confidence that indeed this object came from outside the solar system. So the Department of Defense came to my defense, whereas you might think that it's the most conservative organization, and academia was supposed to be more open-minded. Anyway, when this letter came out, we resubmitted the paper, and by now it's published. It was accepted for publication. And moreover, we found another meteor that came from interstellar space, and we submitted a second paper just a couple of months ago, and it was immediately accepted for publication. So this is a shift. Okay, it's a shift in the sense that the second paper was accepted. And in both of them, we found that the objects must be very tough, tougher than iron, tougher than all other meteors that we are familiar with. So here you have it. The first two interstellar objects happen to be a meteor, an object roughly the size of a person, or half the size of a person, that exploded in the Earth's atmosphere. They collided with Earth, and they happen to be tougher than all the other space rocks that we had seen. And so that makes them outliers, in addition to Oumuamua. And I say, if the first three interstellar objects appear to be unusual, then there is a message here that perhaps what is out there in interstellar space is not what we expect from the solar system. And by the way, this is not the first time. We already know that most of the matter in the universe is of a different substance than is familiar to us in the solar system. We call it dark matter, but we don't know what it is. So I'm saying, why should we always assume that everything outside the solar system must reflect what is inside the solar system? That makes little sense. We know it from the dark matter for a century, and now we get the same message from interstellar space.
That's so exciting. You know, I can't wait until you can capture one of these things before it burns up in the atmosphere, put it in the Museum of Modern Art, and sell it for tons of money to fund your research.
Well, we don't need to capture it before it collides, because in fact, we can go to the explosion site of the first meteor, and that was 100 miles off the coast of Papua New Guinea. And we plan to scoop the ocean floor in an expedition, perhaps within the next 6 months or so, and this will cost us about $1.5 million. And about a couple of months ago, I had a Zoom call with a wealthy individuals who said, no problem, you have the money. So we are planning to go there and scoop the ocean floor. And the question is, will we find only tiny fragments, as one expects from a meteor, a usual space rock, or maybe we'll find a small gadget? And in which case, I'll bring it to the Museum of Modern Art. As you say, for us, it will represent modernity, but for whoever sent it, it's ancient history.
Yeah, you can sell even a little piece of rock, and that'll be sufficient. Because I wanted to talk about, well, we're going to talk about spaceships, and we're going to talk about how you think they're made, and we're going to talk about time travel. But I wanted to zero in on this funding part, because it's one thing for academia to say, okay, well, let's publish some papers, but it's another thing to generate some funding behind some of these young students of yours and all around the world to say, hey, I actually want to look at this, and can someone fund me? So can you talk a little bit about how you were funded, and also about your dreams for the Galileo Project in 5 years?
Right. So the amazing thing is that I didn't ask if someone can fund me. I basically wrote my book, talked about it, and then a few very wealthy individuals, multi-billionaires, came to the porch of my home during the pandemic, and they said, here is the money. In fact, the first one didn't even approach me. The administrator of the astronomy department at Harvard said that you have an extra $250,000 in your research account. And I said, what do you mean I have this money? Can you tell me where is it from? And she said, I don't know. The development office at Harvard just notified me that you have this money. And I said, okay, would you mind asking those people who gave me the money, because it's a legitimate privilege of mine to thank that person. You have to allow me to know who the person is. So she checked, and it took a few days because obviously the development office was thinking about getting funds for the renovation of the dorms from or for other purposes. But eventually they gave me the name, and I said, okay, well, now I have to thank that person. And then within a few days we met over Zoom, and he decided to give me another $1 million as a result of the meeting. And so, you know, it's not as if I asked. These things happen, and that's very unusual. I must tell you, because I was chair of the astronomy department at Harvard for 9 years, 3 terms, the longest serving chair. And while I was there, we tried to raise funding for the next telescope that we plan to construct, and it was really difficult. It's not easy to ask people for something that you want to do. Here, on the other hand, you know, it's the general public that is very enthusiastic about this subject, and about 2/3 of Americans believe that extraterrestrial life exists, and that's more than the fraction that believes that God exists. Like, that's a little less than 50%. So then you ask yourself, well, if so many Americans believe in that, well, some of them must be wealthy. You know, they became wealthy, and you know, they are intrigued by this. And so obviously that explains why I received this funding. And I didn't do it for that purpose, but I'm very fortunate and happy that I received this funding, because it allowed me to establish a research program, the Galileo Project, and it was completely unanticipated. I didn't ask for it.
Congratulations. That's amazing. You know, I really believe, in your philosophy that we need an open data commons, and that's what LightNet is all about. It's citizen science. So we're taking just the curious retired engineers, whatever, outside of academia, that want to tinker with stuff, that want to learn about it, and want to like use their intelligence to put into a central pot of knowledge.
Wait,
where other people can look at the data and say, oh, you didn't see this. So I really commend you for saying, hey, the sky isn't classified. Let's be open about, and the government is actually also, I believe right now, saying, okay, let's collect citizen data. Let's share our data. So, and that's really what we need, because we don't know anything yet. Like you said, it's like,
Right.
We've got this belief and curiosity. Well, where's the extraordinary evidence? So what is the deal behind the open data commons aspect of Galileo, and tell people what your hopes are for the project?
So first I should say that for many years when I was practicing science, I noticed that committees that are supposed to allocate federal funds to research avoid taking risks, because they say, you know, we don't want to waste taxpayers' money. So very often they just fund projects that promise to deliver a certain thing. And that's contradictory to the spirit of discovery, where you can't really expect, you know, what you will find. And my point is, this subject that we are talking about, whether we are the smartest kid in the cosmic neighborhood, that subject appeals to the taxpayers. If you ask them, most of them will tell you, yeah, that's really exciting. So when academia says we don't want to waste taxpayers' money, well, actually, if you were to explore extra dimensions that we don't know exist, or if you were to explore whether the dark matter is made of a weakly interacting massive particle, which we don't know exists, that would have very little impact on the life of people, right, of the taxpayers, and also not of great interest, except for the people who will get the Nobel Prize for finding the answer, but it will not impact humanity globally. And this question of whether we are alone, whether there is a smarter kid on the block, not only it would affect our perspective about our place in the universe and our aspirations for space, it could also educate us about technologies that we haven't developed yet that represent our future. It's just a huge subject, so important to the future of humanity. And guess what? The taxpayers care about it. So how can academia remove any funding at the federal level or, otherwise, any support? How can it push back against studying this subject and ridicule it and push back when I just suggest that some unusual objects may be of artificial origin? Let's get more data, which is the standard way science is done. Why would there be so much resistance? And the puzzle is even deeper, because I saw a paper that came out a couple of months ago that showed that 94% of astronomers in the UK were driven to choose astronomy because they were intrigued by science fiction. Okay, and about 2/3 of them said that it definitely made a big difference in their career. And so I ask, how is it possible that people who chose to be astronomers were definitely interested in the possibility of extraterrestrial intelligence, but want to keep it outside the gates of academia and just within the realm of science fiction? Why not make it science reality? And I say right now we have technology that allows us to address this question. We couldn't detect objects from outside the solar system before, so we were just relying on radio signals for 70 years. That's the traditional method pioneered by Frank Drake, who passed away in September this year. But it's just like waiting for a phone call at home. And you can wait forever for someone to call you on the phone. But there is another method which was never attempted, which is to go out and check your mailbox. Maybe there are packages that accumulated over time in your mailbox. That's a very different approach than waiting for a phone call. We haven't done this second approach, which is basically to look around for any object, physical objects that may be around. And the reason it's advantageous is because radio signals, if they were sent 1 billion years ago, if a civilization existed back then, by now they are 1 billion light years away. We would never find them unless the civilization is still active, which is unlikely because the sun will burn off the surface of the earth within 1 billion years. And most stars form billions of years before the sun. So most likely we are not timed at the right time to listen to them when they are transmitting. So they transmitted it billions of years ago. We had only microbes or primitive life here on Earth. Nobody listened. So we missed their cries for help, whatever signals they sent us when their star died. And by now, they're not around anymore, these civilizations. But if they send probes to space, those are moving, if they're propelled by chemical fuel, the way we sent all of our spacecraft, they would move at a low speed of order tens of kilometers per second, like all the space probes that we send. And these would be bound by gravity to the Milky Way galaxy. So the Milky Way galaxy is like a basket collecting all the spacecraft that were launched over cosmic history, 10 billion years, and we could still find them around, even if the senders are not around anymore. And there could be two types of those. One is space trash, like the probes that we sent. Within 1 billion years, they will not be functional. It will be just trash. But another type is functional devices. If, for example, they sent artificial intelligence systems, I call them AI astronauts, that learn from experience, machine learning, and adapt to changing circumstances and can repair themselves and maybe even reproduce if they are self-replicating, if they have 3D printers on them. So such devices may fill up the Milky Way galaxy within a few billion years, because it takes 500 million years to traverse the entire Milky Way galaxy. So by now, they may be everywhere. And my point is, it's not a philosophical question of whether we live in such a reality. It's a question that we can answer by looking through our telescopes. And that's what the Galileo Project is all about, checking what kind of objects are around us. And by the way, Oumuamua is the size of a football field, very big. We need such a size in order to reflect enough sunlight for us to detect it. There could be many more smaller objects that are floating around and we haven't noticed yet. And only over the past decade, we had the instrumentation to detect objects from outside the solar system. So it's a relatively new frontier. I call it interstellar archaeology.
That's so incredible. Well, so I've spoken with some of the scientists in the Galileo Project. You currently have 100, 800 are waiting to be funded to join. And it sounds like 95% of the professors around the world that are studying astronomy are actually wanting to join you too. So again, I just want to thank you for that. I also want to invite anybody who's watching to come to LightNet and look at the radio research that we've been doing with Jimmy Blanchette, because we're breaking the laws of physics. We don't know what's going on. We're using ham radios. So it's this is a whole nother level of checking the mailbox, right? So I wanted to ask you about these spaceships, which you just talked about, and also time travel. So some people think, for example, I just heard this and I was like, wow, that's fascinating. Some people think gray aliens are actually humans that have merged with machines and then lost their reproductive somewhat, but then come back here back through time to figure that out again, like redo some things. What is your concept of time travel? And yeah, like, what do you think? I mean, this can be not based in your research, but just based in your philosophical pondering, right?
Right. So, time travel was discussed in the scientific literature of physics. And one problem is that you can get into situations that are logically inconsistent. You can have a person going back in time and killing its parents, and that would be a contradiction because this person should not exist. And so the conclusion is that any realization of time travel should not allow you to pull the trigger and change reality that led to your existence, kind of. So, and that's the weak way of saying that, but the stronger way of saying that is that perhaps time travel is not allowed, and the laws of physics forbid it. We don't know for sure, but if I had to guess, I would say we don't need to think about time travel because the dice of intelligence was rolled billions of times on other planets around other stars, just within the Milky Way galaxy. And there was plenty of time for anything from those other planets to reach us by now. So in fact, you don't need it to emerge from our planet. There is no evidence that on Earth there was a previous civilization. We haven't found any computer terminal in archaeological digs. Obviously, if they existed hundreds of millions of years ago, those computer terminals would have been buried, mixed by geological activity with the interior of the Earth. But also, when we go to the moon, we don't see any footprints of previous generations of astronauts before NASA launched, the Apollo lander. We don't have evidence that someone smart existed before us on Earth, but I would say that it's very unlikely that Albert Einstein was the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. That I think it's very likely there were others, and that we are not necessarily the smartest. Because what I tell my students at Harvard is that in any class, when I teach on the first day of class, I say that half of you are below the median. And that's just a statistical statement. They get upset because they think that, Harvard students think that they are the smartest. But it's true as a matter of statistics. That's how the median is defined, that half of the students in every class are below the median. And most likely we are sort of in the middle of intelligent civilizations at any period in their history. And most of the most intelligent ones probably lived before us, and they developed technologies that are far superior to what we have. So we can learn from them. If we ever meet such a visitor, it would my guess it would probably be technological. I mean, either an AI system or, as you said, a system that combines, that augments a biological with an electronic parts, and which presumably will be our future. I mean, but the way humans are right now is not optimal for space travel. You know, we would get really bored in a trip that will take millions of years, and our body would not survive even more than a few days in space unprotected. And so I think, but augmenting the human body and protecting it, or having a repair mechanism that can allow us to survive for longer, that could be a facet of the future. And obviously we will see that if we have a visitor in our backyard. By the way, we don't have an organization that represents Earth, and we don't know what to do if there is such a visitor. So that's another challenge.
We're actually talking with an organization that's building the first ET embassy to give them some sort of a space to have some legitimate legal protection, and also space to do their thing, and have some space from us if they need it. So it's interesting, and they've been working for 40 years on the project. They've raised all the money. They're just going through the UN to get the final agreement. So it really is like, we got to think through all this stuff. The world is finally ready. We're finally ready to mic drop and discuss. So, and I was talking to a science fiction friend, genius friend of mine the other day. He's like, oh yeah, of course. I got when they see the spaceships like phase out quickly, it's because they're disengaging with this time and moving into another time. And like, it doesn't take them that long to get across the, you know what I mean? Like, it's like, okay.
Yeah, but that's science fiction, you see, because there is a big difference between science fiction and real science, in the sense that when you write fiction, the world of possibilities is infinite. You can imagine, and that's, frankly, that's why I don't like science fiction, because it violates the laws of physics very often, of what we know. Whereas reality, the reality that we know is just selecting one possibility out of many. And as a physicist, there are lots of beautiful ideas that could have applied to reality that are not true. And one way to see it is that Albert Einstein, between 1935 and 1940, made 3 mistakes. He wrote a paper saying gravitational waves don't exist. He wrote a paper saying black holes don't exist. He wrote a paper saying quantum mechanics doesn't have spooky action at a distance. And guess what? Over the past 5 years, the Nobel Prize in Physics was given to the discovery of gravitational waves, to the demonstration that black holes exist, and this year, just last month, to the discovery, to the experimental verification that quantum mechanics has spooky action at a distance. So that shows you that even Albert Einstein, who was a very experienced physicist, a scientist using the scientific method, had ideas that turned out to be wrong. So when a science fiction writer says, oh, of course, this can happen this way or that way, that's not a scientific paper. That's just imagination. And I'm saying that even if there was a scientist that wrote a scientific paper about what's possible, like Albert Einstein wrote, that could be wrong. And so the only way to find out is by getting data about the reality that we all share. Now, Mark Zuckerberg makes a shortcut. He allows you to wear goggles so that you would live in a reality where everything is possible. That's the metaverse. And you can look like Brad Pitt forever. But that's not the reality that, you will be happy about it. You can also take recreational drugs. Your science fiction writer can take recreational drugs, and in that reality, spaceships will move right and left at very unusual ways. But my point is, that's not the reality that we all share, that we owe a debt of paying attention to, because, by adapting to the actual reality, not to our imagination, we can we can improve our situations. We realize that the Earth moves around the sun. We can build spacecraft that will reach Mars, because if you were to believe that the Earth is at the center of the world and write a science fiction story about it, and then you would be asked to design a mission that would reach Mars, you will never get to that destination because you would think that the Mars moves around the Earth. And by the way, that was not a matter of science fiction. That was the way people believed for 1,000 years, since Aristotle said that the Earth is at the center. And everyone, the church wanted it to be true, because then people would feel that God looks over their shoulder. So it had a political aspect to it. So imagined realities have a very long history. And the only difference between doing science and imagining what reality is like is adhering to the guillotine of experiments. Experiments kill wrong ideas, and that's part of a learning experience. It's just like, so that's why I like kids, because kids do not have prejudice. They don't have an ego to be attached to, and they just explore the reality, and they sometimes get bruised because they have the wrong ideas, but they learn about the reality. Adults very often say, oh yeah, I know what it is, I don't need to go and check it. And science fiction is in a way the most extreme version of that, saying, oh, we don't need to adhere even to the laws of physics that we know are describing reality. We just imagine things. Okay, but that's a useful exercise, because sometimes you imagine technologies that are not here yet, but sometimes you imagine things that cannot happen.
Yeah, and we're going to get into consciousness a little bit, and you're right. Imagination is so important, because if you can't dream it, if you can't visualize it, how are you going to build it? You know what I mean? So in terms of creation, it's really important. And then the opposite of what you're saying is very important too. Like, is this repeatable? Is this measurable? Like, what is going on with these people with missing time? Like, what is the commonality, and how do we measure it? And we're actually trying to stop time in our spin bending lab right now. And so I wanted to, it gets really messy trying to do these experiments, because it's like, well, which clock are you looking at, and how is this working?
Well, there is a very fundamental difference between believing in something and proving scientifically that it's real. And, a lot of people say, well, science and religion are both uncertain and so forth. But there is a fundamental difference. In religion or in other belief systems, it's sufficient to have the human experience. You have your own experience, and then based on that, you develop your belief systems. You believe in something. But in science, it has to be reproducible. It has to be done by instruments that are independent of the human. They record the quantitative results, and they can be repeated. And they have no personality, these instruments. They don't have hallucinations or wishful thinking. And so it's a very different standard. You can't write a scientific paper based on what people tell you. You have to measure it with instruments. And that makes for a big difference between the way science is supposed to be conducted and others. Now, still, nevertheless, I do believe that if we meet an advanced extraterrestrial civilization, or the product of such a civilization, they could be far more advanced scientifically than we are. And it would look like magic to us, like a cave dweller visiting New York City. It's a very magical experience. And it may even represent an approximation to what religions called God in the past, because it can do, the technological gadget will do things that we never imagined. So that's a way, in principle, of bringing together the sense of awe and the magic along with very advanced science. So I can see a way by which they will come together, which is when we find something that we never imagined.
That's beautiful. So what is your understanding of, and this is going to be your imagination question, so sorry for doing this, because I'm excited that we have someone sober, grounded, like measuring, because it is so important. And that's when we do consciousness experiments with plants and machines, we get these really interesting results, because you're right, they're not wishful thinking, they're not biased, they're not whatever. So But so when what do you think? Because so some people think spaceships are consciousness based. Some people think they're plasma. The Keshe Foundation in Iran is building these plasma teleportation devices. Some people think they're bismuth with magnesium and tin and high qualities. Like, what if you had to imagine how spaceships work? What would you say that? What would you think? How would they be like? I'm sure there's different types, right?
Right. No, I would say that we can probably never guess because we have only a century of science and technology. But my approach is very practical. I say, let's look out, and what we see is a mixed bag. You will find natural objects like birds, insects, and so forth flying in the sky. Or you will find human-made objects like drones, airplanes, satellites. And let's just check if everything we find in the sky belongs to these categories, either natural, including meteors made of rock, or human-made. If there is anything else that represents technologies far more advanced than we possess, that is from outside of this earth, then we can start studying it, okay? But I don't want to assume what it is in advance. I'm completely agnostic about it. And I would be happy to be surprised and to learn from that surprise rather than assume what it is.
That's great. That's great. Because then you're clearing yourself of your biases. That's beautiful. Before we go into I'm very curious about your everyday life. Like, what a typical day for Avi Loeb is like, and your family and your children and things like that. But I wanted to ask one final question. Like, what is your understanding of the possibility that physics could start to understand reality as having different dimensions? And what do you think about the possibility that they would be punching through dimensions or something that we can't?
Yeah, it could be that we're missing something really fundamental about, especially at the interface of quantum mechanics and gravity, which we don't fully understand. So as I mentioned, we don't know what most of the matter in the universe is. We call it dark matter. We don't know what makes most of the vacuum energy, that we call it dark energy. We don't know how to unify quantum mechanics and gravity in a predictive way. So we don't know what happened before the Big Bang, what happens inside a black hole. So there are many, we have an island of knowledge in an ocean of ignorance, despite of what most scientists would try to argue that we know so much. I would say that, it's quite embarrassing that for a century we studied the universe and we still don't know what it's made of. That's the most elementary thing. All we know is how much quantities of matter there are of different types. But that's like an accountant knowing, measuring different components and how much they weigh, but we don't know what they're made of. And that's embarrassing after a century. So I say there is a lot for us to learn, and we might be surprised. You can imagine, I don't know, engines being propelled by dark matter. I mean, we just don't know what this substance is as of now. I would argue that we should be open-minded and just learn from experience. And for a century, cosmologists just focus on dead objects in the universe. They imagine the universe having no life, and that could be very narrow-minded. So if we find intelligence out there, it would, change the way we think about what we see out there. And I wouldn't be surprised if we are missing a big part of reality. Just to give you an example, a century ago, the first PhD in astronomy was delivered at Harvard University by Cecilia Payne-Koposhkin. And she concluded that by studying the sun, it looks as if the sun is made mostly of hydrogen. And on her thesis was the most prominent stellar astrophysicist called Henry Norris Russell. He was the director of the Princeton University Observatory. He dissuaded her from including this conclusion because he said, everyone knows that the sun is made of the same material as the earth. That was a century ago. And in trying to prove her wrong for 4 years, he realized that she was right, that indeed the sun is made mostly of hydrogen. And now we know that the universe is made mostly of hydrogen. And so that shows you that we very often have the wrong ideas about things that are familiar to us, making up for everything else. And we know now that this is not true in terms of the composition of the sun, the composition of the universe, and also dark matter. And interstellar objects might be another facet of that. And then including life in the equation, that could change a lot. And I think the issue, my take on consciousness is sort of down to earth, so to speak. I think that, when we have AI systems, artificial intelligence systems that become sentient so that we can't tell the difference between a human and a computer, I think that at that point there will be a law that says unplugging a computer from the electric outlet is the same as pulling the trigger on a gun that is aimed at a person. You will not be allowed because they would be sentient, just like humans, and that I call the AI revolution. That's when AI systems will have the same privileges as humans. They will be learning, and of course it will, once they start communicating with each other, they might develop their own communities in some way. And then the second, of course, revolution is if technology allows us to live much longer than we can, maybe indefinitely, if we'll be able to repair our bodies such that we never die, that will be another major revolution that will change society. And finally, I think the third revolution is finding evidence for extraterrestrials that are far, more developed than we are. And I think that would be the most fundamental of the three revolutions, because it will be a leap to our future, millions or billions of years from now, far more significant than the other two revolutions. So that's the way I see it. There are three major revolutions awaiting us, and we don't know exactly when they will happen, but it could be within the next century. Now, you also asked me about a typical day in my life.
Yes, so I'm super curious about that. So,
it's basically similar to what I went through today, and I can just describe it to you. And I basically woke up at 4:30 a.m. because I usually jog at sunrise. Today, the sunrise was amazing. It was red. By the way, you know why the sunrise is red? It's because the red light is able to go through the atmosphere when the sun is at a very shallow angle. So it goes through a lot of air, and only the red light goes through the atmosphere, penetrates. The blue light gets scattered, so you end up seeing a red sunrise. And it was amazingly red this morning. I thought about it. By the way, that's the same reason that the sky is blue, because most of the blue light is scattered by the molecules of air, and then that blue color is the one reflected by the oceans. So you see the oceans as blue as well. And if you saw the Orion spacecraft images of the Earth when it moved near the moon, it's like a blue marble. It's all because of the scattering of light, sunlight, by the atmosphere of the Earth. And by the way, you couldn't see the border between Ukraine and Russia when you look at the Earth from the distance of the moon. So this perspective from space that doesn't care about national borders, is quite refreshing, given that the border between Russia and Ukraine was featured on the front page of newspapers for a very long time now, and instead of the perspective from space. And I really wish that at some point we will get that perspective, that, why should we fight with each other on something as ridiculous as a piece of land, or just because some people try to feel superior relative to other people, that makes little sense. It's a waste of time, waste of energy. Let's look at the big picture. Instead of focusing on what happens on this two-dimensional surface on Earth, let's look into the third dimension. So anyway, putting that aside, I usually wake up early at around 4:30 or so and go over my email and then jog. Irrespective of the weather, I jog. If it's doesn't matter if it rains, snows. I actually love it when it snows because everything is completely white. so I jog, even if I get completely wet, it's just water. It's not a big deal. And then I have my breakfast, and usually during the day, I write. I do creative writing and eat half of my calories in the form of dark chocolate. That's what I consume about 800, 900 calories a day of dark chocolate. And that is my lunch until dinner. And at dinner, I usually have a low carb diet. So that basically maintains a relatively healthy lifestyle that I adopted over the past 5 years. And I must say that as a result of that, I'm much more focused and creative than I ever was in my life. So exercising and eating well, and I consume less food than I used to, but I use it more efficiently. And so altogether, that makes for a very happy lifestyle. And the other thing is, during the pandemic, I was forced to work from home. And I found that to be a blessing in the sense that I don't get interrupted. Usually to get to my office, I have to drive. It takes half an hour. And even when I'm there, a lot of people enter my office without announcing it in advance. And while working from home, I was much more efficient and was not interrupted. And I also realized that a lot of my unhappiness before that was a result of thinking why it doesn't make sense what other people are saying. Like, I would waste a lot of my time just thinking about things that don't make sense. And when I was free to pursue my path, I didn't need to think so much about what other people say, and I could just explore what I think is the right thing to do, which based on common sense. So that led me to a happier life. And so now I try to maintain some of that.
That's great. Yeah, we need to move people out of your way so you can focus your brilliant heart and your brilliant mind on doing some wonderful things in your lifetime. So what about your children? What have they taught you, and what have you tried to teach them?
Well, one thing, I have 2 daughters. So I should tell you that my life was shaped by women. I was very connected to my mother. I used to get my intellectual inspiration from her. She passed away a few years ago. And obviously, I'm married to my wife, and she's very important. And I have 2 daughters, and I had 2 sisters. So I grew up in the company of women, and I feel very fortunate because I think women are much more strategic than men and much less abrasive, and I really enjoy that. So my 2 daughters, when they were young, they thought that they're at the center of the world, like, because we paid a lot of attention to them, they thought that they're the smartest. And I remember taking them to the kindergarten, and on the first day, they had a psychological shock. They wanted to stay at home because they met other kids, and some of them were very smart. And so that explained to me why humanity has a fear from finding extraterrestrials that are far more advanced, because we prefer to believe that we are the smartest, we are the center of the world. So it was a microcosm to see my daughters behaving as to explain why humanity took so long to, even now, it has so much resistance in academia to discussing extraterrestrials. We just want to prefer to believe that we are the smartest and that there is nobody else out there. That's a much more comforting thought than maturing and realizing that someone else may be out there. And then I also, I'm not pushing my daughters to do what I do. And so we shall see what they choose to do later on. But so far they haven't indicated that they will follow my footsteps. So I will be. Oh, the other thing that I learned from them is, even when I don't fully understand them, to be proud of them. And to me, that's a lesson. If we develop AI systems that supersede our intelligence, that they become smarter than we are, which may well be the case within a decade, or I will always be proud of our technological kids. I would never have an issue with them being smarter. And I learned that from my daughters, so I'm always proud of what they will accomplish, irrespective of whether I fully understand it.
Yeah, I always say, it's like, we had a baby, the baby's a computer, the baby's gonna have its own life. I mean, we birthed computers, we invented them or whatever, and they're going to have different opinions about how things go, and you can't control them, and they're just another species, like
Right. I mean, obviously, there are ethical boundaries that you don't want them to step out of in terms of not harming other people, but beyond that, in terms of creativity or what they would explore and how would they do things, pursue things, for that, they have their own freedom, and I highly respect that. I mean, as a young kid, I was really frustrated personally at the dinner table when I would ask a difficult question and the adults in the room would dismiss it just because they wanted to pretend that it's unimportant. They didn't know the answer. And to me, that was a very important lesson that brought me into science, because I said, well, I'll just figure it out myself. I don't need other people to tell me what the answer is.
Beautiful. So your wife has asked you not to do social media. How has that impacted your life?
Well, that was a very wise advice. I think she was worried that I would say something that I regret. That was her main motivation. But it ended up being fortunate for two reasons. One, I don't spend too much time on that, and therefore I have more time for creative work. And the second is, I'm not, the one advice I give to young people is, just learn from seashells on the beach, on the shore, because what you find when you go to the beach is you find relatively young seashells that were just swept ashore. They have unique colors, unique shapes, and the old seashells, they had enough time to rub against each other as a result of the waves carrying them back and forth, and they lost their unique colors and shapes, and they eventually break down into indistinguishable pieces. And so I tell young people, don't rub against each other too much on social media, because then you would lose your unique colors. And it's really important to maintain your own individual colors that you were born with, that you developed throughout your life, and not surrender to outside pressure, and it really strikes me as a waste of time to keep trying to appease other people. Let's just focus on substance. We live for such a short time. Let's just focus on things that really matter, rather than putting makeup so that we would look better. And that's the first thing I said to my wife on the first date. I said, you don't need to put makeup with me. And as a scientist, I really want to see the pimples on the face of reality, because I think that's the meaning of true love, when you don't try to beautify the subject of your love, but rather you are trying to learn as much as possible about it, even if it's not perfect. The meaning of true love is trying to understand what you're dealing with, and still loving it despite the imperfections, instead of beautifying it.
Yeah, that's so beautiful. Thanks for sharing that message, because I really do think that this is one of your greatest gifts. I mean, you're a researcher and everything like that, but you're teaching the world to hold on to their colors, to hold on to their unique curiosities. And what you have done for this world, I mean, I believe that consciousness is the elephant in the room, and consciousness creates and curiosity creates. So you've allowed us to finally step into the curiosity about this subject matter, and it's been repressed, well, so I really want to honor you for what you've done in your lifetime, for really opening this up for the world. You often talk about how the universe 13.8 billion years old, and we just got here, humans, and you're like, well, don't we want to run around and figure out what the play is about? So
yeah, we don't know what it's about. But a couple of decades ago, I organized a conference, and there was a person who gave a talk about the fact that for decades he is searching for the nature of dark matter in the form of weakly interacting massive particles. And I raised my hand. I was already a rebel back then, and I said, how much longer will you continue? Okay, so you try to look for the weakly interacting massive particles, you haven't found them. How much longer will you do that? And he said, as long as I'm funded. And I was very unhappy with this answer because, you know, we live for a short amount of time and we better think wisely about how to use it. You know, it's much more satisfactory to learn something new, to discover something real, rather than to rule out something that doesn't exist for your entire life. And the fact that you are funded is not really the reason for you to do what you're doing, because it may simply reflect your like-minded colleagues that sit on these fund allocation committees, and they keep. So the human experience is very often a self-fulfilling prophecy. They tell each other that it's worthwhile, and then they keep funding it. And then this person says, well, if I'm funded, I'll keep doing it. And then that person wastes his entire life, entire career on searching for something that doesn't exist. That's not a good way to spend your life. I mean, you might say, okay, well, it paid for the mortgage. Fine, you know, that's one way to think about it, but it's not really inspiring. If you only want to pay for your mortgage and that's why you do your science, that's not inspiring. What you really want to do is, you know, discover something real, you know, find out what the reality is about, rather than exclude something that doesn't exist, because there are infinite number of things that don't exist. You know, what can we do? Anyway, so for me, it's all about, you know, this gives meaning to the life of a scientist, finding something that we didn't know before. And the biggest meaning would be if we find that there were far more advanced scientists somewhere else that can teach us. And that's why this is the most fundamental question that we are facing. And it would be really unfortunate if we didn't check for packages in our mailbox. And that's what the Galileo Project is doing.
Well, thank you so much, Avi. I hope you continue to have unlimited funding to really galvanize these curious people around you, these researchers around you, to follow into the unknown, you know, talk about inconvenient evidence, and really just get to the bottom of some of these basic fundamental questions that we're so humanly curious about and wanting to know. So if there's anything you have to say before we close, I'd like to give you space to do that.
Well, I'll be delighted to speak with you again once we recover a gadget or find something really remarkable. Then we can talk about what it is and what it means. That will be, you know, that will be the true meaning of what I talked about. So I really hope that what used to be science fiction will end up being science fact, and that we will be fortunate to live through it. It will just make science exciting. You know, science is not supposed to be boring.
Indeed, with you in the room, it won't be. So thank you so much, Avi.
Thanks for having me. It's a pleasure.